Okay. Hey, Kayla. So what I thought I would do is work through the first two questions with you, and I'm going to use different numbers slightly, so it won't be the exact answers, but it should help you in knowing what you're supposed to do to answer those questions. So the whole idea behind this, especially with question one, and why we want to calculate that PPFD, is because that value is more accurate when it comes to the light that's important for our plants. So if I pull up this, unfortunately I don't have my nifty like keypad and pad with me, so this is going to look rough. But if you remember from the lecture, if we are doing a graph here of light, and this over here is blue light, that's supposed to be a B, and this is green, and this is red, right? So this is the visible light that is produced by the sun or an artificial light. This full spectrum right here, so it includes all of this, is what we refer to as PAR, P-A-R, and this full spectrum of light is what is utilized by our plants, right? They use this entire spectrum of light from blue light all the way to red light. Now, how we have measured light historically is through what we call lumens. And lumens really center, they're based on our visual perception, and our visual perception is really good at seeing, it's really good at seeing light in this green and yellow region that you find right here, right? So it's really good at seeing this type of light, but it's not good at seeing blue light or red light. So I don't know what that means. So the problem with using lumens as a measurement, if we're trying to assess the quality of a light for plants, is that lumens are only really good at telling us how good or how much green and yellow light there is, and not so much blue and red light. And as we learned from the lecture, this blue and red light is really important for our plants, particularly for photosynthesis, right? That process of photosynthesis where our plants take carbon dioxide and water and they convert that to sugar, essentially a food, that they preferentially absorb this red and blue light for that process. So because of this, that's why we tend to not want to use lumens. And I'll just write, again, sorry that it looks so awful, but we tend to not want to use lumens. And if we're using lights for artificial lighting for plants, we'd rather use this PAR measurement. Now, this PAR measurement is just the light in this spectrum. We also have something called PPF, photosynthetic photon flux, which is if we're assessing a light, it's how much light in this spectrum is being produced each second. And then the value that you have to calculate for your activity is PPFR, photosynthetic photon flux, or PPFD, density, right? And that is the amount of this light that is being produced each second that is landing on our plants. So if we were going to have a grow light, and ideally we want to know how much energy in this spectrum that our plants are going to use is going to be produced by that light, and it's going to land on our plants. Now, in order for us to calculate this value, we need to know this PAR and this PPF value, and then we need to know where that light is in relation to our plants. So this PPFD is going to vary if our light is very close or if our light is very far. And you can think of it just on your human perception, right? If there's a lamp post and you are 100 feet away from that light, the light that's going to shine on you is going to be much dimmer than if you are right up against there, maybe a foot away. It's going to be a lot brighter. So that's why the distance from where the light is to your plant is so important. Now, the problem with this PAR and PPF and PPFD is that a lot of light manufacturers still utilize lumens as their measurement, right? And they also they use lumens, and they'll use what we see as lux. And lux is essentially the equivalent of this ppfd value when you're talking about lumens, right? So ppfd is the amount of this par light, or the amount of the light in this spectrum that is shining down per second on your plant. This lux is the amount of lumens, so light in this spectrum, that is shining down per second on your plants, right? So they're essentially equivalent values. So when you go to look at artificial lighting, you may see it'll tell you a lumen value, or it may tell you a value of lux, but it doesn't necessarily, not all of them will tell you this ppfd value. And that's really what we want if we're going to judge lights and know what type of light we want and how many lights we may need for what plants we're growing. So in order to get this value, luckily, there are websites and tables that will allow us to convert lumens to lux, and then lux to this ppfd value. And that's what you have to do with this first question of your lab. So if we pull it up here, the first question is that you have this following light set up. And I give a link to it, and we're going to go to it in a second. And the question is, the light is hung 12 inches above your plants. Assume a beam angle of 60 degrees. Calculate the ppfd. Well, if we look at this, and it's actually already in the title here, but I'll pull it up here, and forgive that I have 1,000 tabs open. But here is the link, and it takes you to this light here, and this is what we're growing. It's a fluorescent light, and it's producing 5,000 lumens. So that's good. It's telling us some information, but again, we don't really want to look at lumens. We want that par value or that ppfd value. So luckily, we can take this and we can use a website that I have included in your PowerPoint. So if I pull up your PowerPoint, if you go to this slide right here, this link here will take you to a website that will convert lumens into that lux value. And then if you have that lux value, you can use this table here to convert it into the ppfd. So I'm going to show you how that works now. And we're going to use a hypothetical. I'm not going to use the 5,000 that you see here, but when you do this, that's what you're going to use. So I'm going to use a hypothetical number, right? So I already have this website open already. So we'll go back to here, and this says it's 5,000 lumens, but for our case, we're going to say it's producing 7,000 lumens. Right, so here's the website. If you go to it, it'll pull up this. It's a lumen calculator, lumen to lux. So you'd go down right to here, and you would see, right as I did, you would type in your 7,000 lumens. But then in order to get the lux value, which is this right here, you need more information. So it's why I include, you need the radiation angle, so the angle, the beam angle that's coming down, which is why I included it there, and I think I said 60 degrees. So you would type that in, and then you need to know the distance from the source. Again, it's that idea, the closer your light is to your plants, the more energy your plants are going to get. So in this case, I said 12 inches, so you can convert this over here to inches, and you would type in 12. And that is going to give you a lux value that you see right here. So then what you can do is you can take this, so 89509, and I'm going to pull up a calculator here. So 89509, and we're just going to remember that value. So that's how many lux your light is producing. So if we go back to here, that's how many, with a light hung 12 inches above your plants, it's producing that many lux. Now we need to convert it to ppfd. So to do that, we once again go to this, and this is our table of conversions. So we find what type of radiation source it is. So we were using a fluorescent light right here, cool white fluorescent. And then this number is the little conversion factor. So you multiply whatever your lux is times this number to get the value in ppfd. So in this case, it's 0.014. So we have our lux, which is right here, and then we multiply it by 0.014, And that is going to give us our ppfd value. So in this case, it would be 1,253, and you could just leave it as that, as a whole number. So that would be your answer for question number 1. But again, I did this with looking at 7,000 lumens. So when you do this, you have to use 5,000 lumens instead. So hopefully that clears some things up for you. Now, if we go to the next question, that's question number 2, we need to calculate the daily light integral. So the daily light integral is essentially that ppfd, so how much light is landing on your plants throughout the entire day. And to calculate that, you once again need to go back to your PowerPoint, and you see the equation down here. So to calculate daily light integral, what you do is you take your ppfd value, which if I pull up our calculator, we have right here. You see you have to multiply it by how many hours of light are in the day. So if you go to your question, it would say there are 13 hours a day. So your light's turned on 13 hours a day. So you would have 13 hours of light. So you multiply that by 13. And then you multiply it by this value right here, 0.0036. And that's just in order to change the ppfd is in micromoles and daily light integral is in moles. So essentially, it's just an extra conversion factor that you have to multiply by. So you do ppfd by the number of hours of light in your day, and then you multiply it by 0.0036, and that gives you your daily light integral value. And why this is important, how this is helpful, is that different plants have different daily light integral requirements. Typically, you want to get something closer to 30. That's a very high amount. But really, anything between 14, 15 to 30 is good. And in this case, we're even above that, right? So our plants are getting a lot of light energy throughout the day, and it should be able to produce, they should produce high quality plants then, if all other conditions are good. So that's essentially the answers, or how you would work the first 2 questions. The third question talks about light spectrum, right? So you can go back to this. If you go back to the Amazon link, and specifically if you look here, that tells you the spectrum of light produced by our light here. And I kind of want you to evaluate whether that's good or bad, or what you think of it. And to kind of answer that, to get stuff, if you go back to our lecture, if we look at light quality, I kind of talk about the different important aspects of these different types of light and what they do and what might be a good type of light. So I would say read through that or go back and listen to the lecture there, and that may help you there. And then for this last question that I pull up here, I want you to compare these lights. And again, you can do this in different ways. You can look at the light quality, so that light spectrum. You can look at the light intensity, so you can convert all of these into ppfd or just compare them by how many lumens they're producing. And just want you, based on the information here and other considerations, if you think about it, maybe energy requirements, maybe the ability to change out LED light bulbs, whatever you think, what would be your ideal light based on that? And again, there's no real wrong answer here. As long as you can justify your answer, then it's good. So hopefully this is helpful to you. If you have any additional questions, let me know and I will try and answer them for you. Or if this is not, and if you need a little more, we can always do a Zoom. So let me know, but hopefully this helps, and I will see you later.